All righty. Okay, cool. Hey, there we are. So welcome everybody to the Aftercamp meetup. Just quick introduction. The Aftercamp meetup is a meetup founded by Rachel and myself. My name is Scott Bermander. I am a principal software engineer at a company called Nerdery. We are a digital agency. Rachel is a technical sourcer at goodtime.io. So she is definitely the HR yin to my development yang, if you will. So we have spent a significant amount of time in the CS and bootcamp spaces. And we founded this bootcamp or this meetup to really kind of help with what's next. So I think that there are a ton of topics that's, yeah, if you can mute yourselves. There are a ton of topics in really post-graduation that don't really get covered very much. And it really depends on where you end up and kind of what your senior leadership is like, what they decided to teach you. So really this meetup is focused on covering topics that you may or may not get based on where you end up. And so we have a pretty rich YouTube at this point. I think we got, gosh, I want to say like 11, 12 videos up, and we keep adding them every month, 1 or 2 a month. So good topics. I'll share the link for that later. Once again, just please mute yourself. I think I can mute you, maybe. No. If it comes to that, I will mute you. That way we can get it going. I'm trying a new setup tonight too. I noticed that my laptop really struggles when I do the video thing and I try to do the screen share thing. It lags quite a bit. So we're trying a 2-computer thing today. So tonight we are talking 12-factor apps. And this is a really interesting topic in that I find that often if you've been in development for some time, you're like, but you haven't heard of 12-factor apps, you're probably like, what's that? And then you go look it up and you're like, oh, I'm doing that with minus 1 or 2 of the 12. If you're new to development, chances are also pretty good that if you graduate from a CS program or from a development bootcamp, you actually probably, like, by proxy, have got some of this stuff as well too. So tonight's conversation is really about just like covering the 12 and the varying level of detail. I'm not gonna be able to get into like all 12 in depth tonight. There's just no way. But I kind of want to like talk about the opposite as well too. So like what is like anti 12-factor app a little bit, because I want to paint some contrast for you. So part of what I noticed too is that the development industry is exploding. Certainly over the last 5 years, more and more people are getting into it. And so it's just rapidly increased how many people are getting into the industry. But I'm going to talk to you a little bit about the way things were 10 years ago and a little bit beyond as well too. Because I don't think you realize how good you all have it. And I would say things like, that's like, not important, but you're still going to run into companies that you'd be surprised about how many people break some of these rules. So with that, we're going to talk 12-factor apps. Probably plenty of time for questions too. Feel free to enter it into the chat. I'm going to try to do my best to, in this new setup, to keep an eye on everything. That's the vision for the setup. So if you got questions or commentary, please feel free to throw it in the chat, and I will pause and we can discuss if you want. So I'm going to try sharing my screen. Hopefully this whole thing goes off without a hitch. So let's do this. All right. So you can check out 12factor.net, and I think this is a good primer for the 12-factor applications, although it's a little tricky to read. And so hopefully tonight is about interpretation for you and kind of like Scott contextualized this for me. That's the goal. So it is as a quick intro, the way they intro it, it says in the modern era, software is commonly delivered as a service. So web apps is typically what we call these, or the more popularized name, software as a service. And then you probably have heard platform as a service, infrastructure as a service. But our web apps are basically software as a service products, or SaaS, is kind of the other way. Would not be confused with the front end framework SaaS, SaaS as in software as a service. Okay. Peyton, that was for you, buddy. Okay, so the 12-factor methodology is for building software as a service apps. And really the big focus is clean architecture, clean context, clean contracts, declarative formats. Security is layered into this as well too. And scaling is a massive part of this as well too. So scale up and scale down. And this really ties tightly into cloud services as well too. You can kind of we can be thinking about our AWSs, our AWSs, our Azures, our Herokus to some extent. Basically, if you're developing your applications in a certain way with 12-factor apps, working with the strengths of those cloud platforms becomes easier to do. So I'm going to breeze past most of this. I don't need to get into the kind of background. You're certainly welcome to do that. I just want to hop right into the 12 factors. So the first one is code base. Now, this is like, you're probably like, oh my gosh, Scott, are you serious? Why is this a 12 factor? Like, it seems obvious to me that we'd want to keep things in version control, which is what this first factor is all about, is version control. But I will tell you that the adoption of Git is really only like a 7 or 8 year old thing. In fact, back in 2011, I was working at a major enterprise, a huge retailer. And I was literally passing code around on a flash drive. I'd like walk from one building, 2 buildings down to go like bring my flash drive to a desk for somebody to like get my code. It was crazy. I just like that sounds like a long time ago, 2011, but like I just want to contextualize this for a second. So I looked this up. In the box office in August 2011, when I was doing that, was Harry Potter and the Deathly Hallows 2. So like it's not like Harry Potter, like Deathly Hallows 2, we weren't really adopting that. And then the Billboard Top 100 had Party Rock Anthem by LMFAO as the number 1 on the Billboard. So like that stuff was, maybe I don't know, old, and maybe that was long ago, but it doesn't feel like that long ago. So the point here first is that in order to be 12 factor, in order to be like 12 factor compliant, green check mark, right? You have to use version control. So, and then it says, obviously there's a couple different, they list a couple different, I think Git and Subversion are probably the 2 biggest, I would say, in the past 10 years, it feels like. But Git becomes a really central part to working with the cloud platforms. And so like a lot of your deployments will work through Git, but really like just like organizing your code in a code base, distributed version control like Git, and then using a platform to distribute that code like GitHub, Bitbucket, GitLab, all of which I use professionally, by the way. I know a lot of people think GitHub when they think like cloud platform, but Bitbucket is owned by Atlassian, who owns Jira. And like there's some really cool tight integrations there, like click, and Peyton taught me this, you can just like click and create a branch based off a ticket. And that branch can create a branch, or sorry, you can click off the ticket and create a branch. It's super easy. So it's really cool, some really cool integrations. So yeah, I think just the note here, and I don't want to berate this point, is that basically version control is the first factor. So we're using version control. And then of course, branches and code, or the code base, or the branches work for deployments. And we'll talk a little bit about that here in a bit. So not too surprising. The second one is the use of dependencies, and really starting to just like declare and isolate your dependencies. And so I'm going to contextualize this in 2 languages. One is in the JavaScript ecosystem, and the second is in the Python ecosystem. So first and foremost, you want to have a manifest for all the dependencies of your application. You want to isolate those. So this is like the use of a package.json in the Node ecosystem. We're saying, hey, I need to npm install these various modules and packages to get this application to work. That's what that whole concept, this factor right here is what that concept is based on. In Python, it might be a requirements.txt, you might be using pip. And definitely, I think that Python does a better job of like really realizing this with the virtual environment. So Vemp is probably what you've heard of, is referred to as too. And so that's like true isolation of dependencies. And the focus here, the reason why we want to do that, why that's so important, and you're going to see this threaded through a couple of these factors, is that the goal of creating your application is to make sure that it can run on its own. It doesn't need any other dependency outside of the application itself. So this would be things like, I'm trying to think of a couple of good examples here that would make sense. Curl is a great example, like making sure that your environment that you're working on has curls, and that you can go ahead and like hit certain URLs. So really this isolation dependencies becomes a really huge deal in 12 factor. Once again, as we look at some of these other factors coming up, we need the ability to turnkey and scale up and down your application And so isolating those dependencies is super important. I would also say that most of the modern frameworks do have this. And I will tell you that this is so much less of a pain in the ass now than it was 10 years ago. And this is why, like, even 10 years ago, it was pretty awesome to be an action script developer, which is like Flash, because like that was like the walled garden. Like you didn't need really anything else. It's all self-contained in the plugin. You guys can make fun of me for liking Flash, but that's the thing. Okay, there you go. Pip with Venv is listed for isolation. So they called it up too. It's probably where I got the idea subconsciously. Okay, configs. This is super important too. So when we think about creating applications, and you probably have learned this in your bootcamp or your CS study or even independent study, maybe you haven't, this is a big deal, is you want to avoid having hard-coded configuration in your code. So what do I mean by that? I think I have an example pulled up already. So here, I'm going to run a quick check on this. Get process venv, perfect. There you go. Here's a little snippet of code, kind of what I'm talking about. So this is a pool file for a Node Express application. And what this file is used for is it's used to connect to the database. Now that connection happens essentially when we pass this config into this creation of a new pool or this new connection to the database. So if we just work this way up, this is the actual established connection. We take the config, and the config comes from up here, and params is listed as part of the need of this configured options. So right here, line 7, here's what this line is all about. We're creating a params object, and we're parsing out a URL, and it's taking in an argument that's coming from process.env.database. Now, what this is really quick, process.env is essentially where am I running and what environmental configuration file do I have to get set up. So, and then we're looking for the database variable. Now I pulled this off of my GitHub repo, and essentially what it's looking for is some sort of file that looks like this, .env. And I could then go ahead and create that variable, copy that, paste it, and then set it equal to something, whatever.com. You get the idea. So there's some value that's listed as a variable in this environment file. Now, the other place that we could get it would be through the provider, meaning the cloud host. So the common idea here would be something like a Heroku or an AWS. Now, what's cool about this code is that it is process and environment aware. Like, right, when I go post this code on GitHub, or sorry, on Heroku, when this code runs, it's written in a way that says, okay, if my environment is local, I will pull out of this env file that is sitting in the code base. But in Heroku, it's something different, right? On a cloud platform, it's something different. So let's actually go ahead and pull open an example of this here. So I got a Heroku application. This is actually for Aftercamp.com. So here, and I don't want to reveal it because I don't want to reveal my configuration settings, but here I essentially set this same thing. It's like a key value pair. And so it works similar to the way that I'd be working in this environment file, where I would list the key, in this case, database underscore URL. And then the second input, I would list the value. And this is typically something provided by Heroku or whatever service you're using. So here's the point of this factor, is that this code does not care where it's being run. It is set up in a way that it can adapt to either scenario with no additional effort on my part. All I need to do is configure the environmental variables, and then it's set to go. And that's kind of the point, is that when you look at 12-factor, 12-factor is really based on this idea that your code is like in isolation, and it doesn't really, it's modularized in a way where it doesn't really matter where you stick it. It works great. And as we'll see in some of the other factors, this plays more and more of a bigger part. But I think from a security standpoint, it's also really good, right? Like, I think, I've talked to my students about this a lot. Let's say we had an API key to access a third-party API. What I would want to do is I'd want to put the API key locked behind an environmental file. And so this could be something like OpenCage is an API I really like to use. This one, OpenCage can take coordinates and convert it to cities, or can take cities and convert it to coordinates. It's pretty cool. So I'm just making up just some sort of like key. This isn't a real thing, but let's say this is my API key provided by OpenCage. I wouldn't want to take this key and plug it hard-coded into the file. I wouldn't want that hard-coded because I would like post on GitHub and somebody could take my key. By the way, this is a thing that happens all the time. There are bots that go and script GitHubs for API keys for malicious intent. And it's actually something I look for when I'm screening candidates. I actually look to see, and like, did somebody put their API key in their code? All right. The question was, is the environmental file just in the root directory and node runtime picks it up, process env, and it turns out an object JSON? Almost. Oops, excuse me, I didn't mean to bump that. Almost. There is a node module for environments. So if I go back to server, there is a npm module install called .env, and you basically run the config right out of the gate. Now, if you're using TypeScript, this looks different, but you can check out the .env npm module for more information on that. But essentially, yeah, all the data is sitting on the process.env then, and you can pull it right out. So it .env looks for this .env, and then of course we do a git ignore on this. We'd say, hey, we want to make sure we're not. In fact, I think in the auto-generated code, yep, most auto-generated code goes ahead and runs a git ignore on .env. Okay, so that is, that's garbage. This isn't real. Get the idea though, don't save. Okay, cool. So we want to abstract out any of this key information, especially when it relates to configuration, like where is this thing going to run? And then definitely anything security considerations as well too. Those are two very important things to abstract away. Okay, so back to the 12 factors. Let's go to, how am I doing on time? I'm doing pretty decent. Okay. Backing services, and this says to treat backing services as attached resources. This one's going to require just a hair of a bit of a deep dive here. So I'm going to actually pull open Lucidchart here. By the way, Lucidchart is a phenomenal diagramming chart for tech. I can make all sorts of charts in here. Let's go ahead and open this up. You can create all sorts of architectural diagrams to help explain what it is that you're going to build to your clients and your team. This is a pretty aggressive one, so if you're like, what the hell am I looking at? Don't worry about it. This is an auto-generated one. It's not like I made this. This is something that Lucidchart supplied. But for tonight, I'm going to use this to help us understand this concept of backing services and probably a couple other ones. So the typical diagram that I like to create is you have a front end, and this would be like your HTML and CSS. You have your client code, and this would be like your React, your Angular, jQuery, Vue, anything you're writing to write logic on the front end. And typically those are being run by some sort of browser, and I use Chrome as my example for that. Okay, and then we have the internet, and typically data flows from the front end to the client flows through HTTP call like an AJAX or a fetch, an Axios get, whatever you want to use, off to some sort of server. And then the server typically communicates with the database. And this is the very common pattern that you learn in bootcamp, or if you're doing self-taught. I think CS does a little better job of breaking this up. And in one of the meetups, we talked about this concept that we might want to decentralize or decompose our server into multiple services. So the example I'm going to give here will be, let's say I have a website that you could order product from. So this idea would be, maybe I have the ability to log in. I then have the ability to look at products, and then I have the ability to place orders. And so the idea here might be that we have one server or service that handles incoming traffic into the application. And then I might have additional servers or services to handle the various parts of the application. And this is like an imperfect system. We're just kind of doing a rough sketch. So the idea would be this, that maybe this is my customer or user service, and then it has a backing database. This could be a product service. And then maybe I have an order service. Now, this factor has a lot to do with how we start to think about the arrangement of our application. So if you're graduating from a program, like a boot camp or a self-directed sort of thing, this might look really foreign to you. And I know this because I look at a lot of curriculum from a lot of places. The typical, like when you learn how to build an app, like a to-do app, for example, they're not big enough to start to decompose, meaning like you don't want to like start to pull apart the app into separate apps because there's no need to. But the reality is that you might it might make more sense when you start working at apps that are at scale. So, and you probably don't really start learning that until you take your first job as a developer and you start to really work with more of the backend team. And you start to say, hey, maybe what I want to do is I want to start building additional, essentially, servers. I'm going to oversimplify that statement. And we are going to use HTTP communications to communicate between these servers. So essentially what we're doing is we're inserting, I'll make these smaller because I'm going to do a lot of them. We're inserting basically new applications that require the internet to communicate over to. And you can do like intranet, and there's all sorts of like virtualized networks and stuff you can do to simplify this process. But essentially we're doing this, and we're basically decoupling the applications. And so what this allows us to do is that if for some reason this service fails, I could, if I couldn't log in, I might still be able to look at products. And if you've ever been online shopping in the past 5 to 10 years, maybe that's happened to you, right? Maybe there's some part of the site you can't use, but other parts of the site you can use. And there'd be like a graceful way to handle failure, like, hey, you can't log in right now, service unavailable, but like you can still shop products. Hey, you can't pull up your orders right now, but you can still log in and add to your cart, that sort of thing. Okay. So what does this factor have to do with? And it says treat backing services as attached resources. That's essentially this idea, is that purists might actually break this out even further. And we actually would say, let's go ahead and insert an extra layer into the service where essentially we have the user controller, and then we have the backing service for the other part of the database. So 1 second here, I'm just going to do, okay, cool. So basically what we want to do is we want to start to decouple and detach these resources away from each other. And what's cool about that, they're like, the reason why you do that is it creates a more fault tolerant system. But as we'll see too, it allows us to like scale up and scale down certain parts of the application to be more performant. So great example, this would be, Black Friday. We want to start to scale up some of the portions of our application. Or if you're working on I like to use pizza websites. I think pizza websites are fascinating to me, like pizza restaurants. It's the Super Bowl, and we want to like scale up the ability to take on more orders, but after the Super Bowl, nobody's gonna eat pizza, so we're gonna scale them back down. But if you don't have your application decomposed like this, right, you are essentially scaling up your entire ecosystem, meaning that you are literally like probably not quite this extreme, probably pointing to the same database, but you are probably provisioning whole entire sections of the application you didn't intend to. So the idea of this factor is to decouple, creates a more fault tolerant system. And the idea is that they'd be a little more interchangeable too. I could talk at length about this one. I could probably move on or to some of the other ones. Okay, let's go to the next one. Build, release, run. This has everything to do with CI/CD. And CI/CD, if you have not heard that term before, is continuous integration and continued deployment. Now, CI/CD, I would say once again, is kind of an emerging emerging, I guess, concept or discipline, in that as the DevOps side of development becomes more mature, the tools get more mature. There's a lot more, like, this is becoming its own like ecosystem. They definitely hired people to just do CI/CD, and that's all they do. That way the developers are not focused on this piece. Well, let's talk about what CI/CD is. Okay, and I have a very simple, super simple example of this. So CI/CD essentially deals with this concept that we have our code that we post to Git, and then it goes through some sort of automation process, and then goes live into the web. So we, I don't know, let's do code on my machine, gets posted to GitHub. That's what's going on here. Sorry, the graphic is not super mature. Goes through some sort of automation process, and then eventually ends up deployed. Now, what this means, or why is this important, is basically I would write some code, and maybe we commit it to a branch. Payton and I decide that we're done with our feature. We merge that branch into the develop branch. I could then kick off a CI/CD process to run integration tests to see if the code we wrote breaks the rest of the application. If it doesn't, if it's good, then what we can do is we can go ahead and move that code to dev or to staging or to whatever flows in our system, which is actually another factor. So we'll kind of skip ahead here a little bit. But let's get a new document. Essentially, we have this flow of events that says, I post code, so let's go back to this. I post code to version control, kicks off automated process, then moves code to new place. And I actually have an example of this. So let's go ahead and just do, it's a non-testing example, but let me show you this in action. So I have the Aftercamp website. And if you scroll down, I'm super proud of our 350 members that we, or 300 members that we have, but we're actually at 360 now. So I'm like, well, maybe I want to go ahead and bump this number up. So let's go ahead and bump this up to 350 really quick. So I'm gonna go over to Visual Studio Code. You get to see the horrific code that is the landing page. It's one giant React file because I haven't decomposed it yet into separate components. But I'm gonna go ahead and change this to 350. So I think we got like 360 some members now. So now what I'm gonna do is I'm gonna make sure I'm in the right directory. I'm gonna say git add dot git commit message updates member updates member count to 350 plus. And then I'm going to do a git push origin, and this is still called master. It was made before the switch. Okay, I'm going to press enter. And what I'm going to show you here is hopefully Heroku. There we go. Over on Heroku, I have it set up where it is connected to GitHub, and it is listening for essentially this repo on GitHub to get an update. And when it does, normally what I could do in CI/CD is run a bunch of tests. This is a landing page. There's nothing to test. It's static text. So no tests, but if there were tests, I could run those. But now what it's doing is that it is auto building because from a CI/CD process that I set up. And so it's auto updating from that repo on Heroku. So by me pushing that code up to GitHub, I set up a pipeline to actually update the live website as well too. So the build is currently in process. I did that all through git commit, and it's all automated. The rest of it, not granted, you're like, Scott, it takes one extra freaking command in the CLI to get that updated, but whatever. It's saving me some keystrokes. So the build is automated. It's working through. Now back to this in terms of, we'll look at that here in a little bit. This could take a minute. Back to the 12 factor side of things, is that from a 12 factor standpoint, if you're doing everything correctly, here's the way it works, is that you write code and you post it, and the build automation kicks off. It then becomes a release, and the release is dependent on config files that you've set up in an externalized environment. because you wrote your code in a way that's not dependent on those values inside the code itself, it takes it off a configuration file. And the idea behind this is it makes releasing to different phases of the development process a little bit easier. So because you've externalized things, this process becomes kind of more step-by-step. Okay, I'm talking around another factor, so I'm hoping this one is, let's skip. Let's see. Let's dive into 10 and then I'll move backwards. So this is this dev prod parity. So I'm gonna back up a second and talk about the way that we usually set up environments for development for clients. So if I'm working on my code, I'm typically working locally, meaning that I'm working on my code on my machine. So this is like Scott's machine, that's the phase it's in. When I feel good about where that code's at, I would create, of course, it'd be branched off and I'd merge that branch in. And once I get that feature merged in, it goes to an environment typically called dev, or for development. So you call it development or develop. Now, once that feature is stabilized and we're feeling pretty good about that, we then would say, okay, that then needs to go into, and I've seen this go two different ways. So I'm gonna actually just draw it one way and then we'll talk about the other. Once that feature is accepted, it could go to QA or it could go to staging. I'm going to say QA for tonight. QA then basically tries the feature out in their own environment. When I say environment, here's what I mean to be really clear. These are separate URLs, right? These are places that have been provisioned, very similar to like Heroku create. When we say Heroku create, it provisions an environment for us to post our code to, and we get things like shimmering murmur 65392, right? Some random name. That's a provisioned environment. So if it helps, what you can think of this as, these are like 4 different actual Heroku applications, because those are 4 different places the code can land. So we're testing away from what eventually is what we call prod or production. Prod is what the user sees. So there's a couple of gates that we get to before we get to prod. So here I'm testing things out in develop, just making sure it's working on an internet HTTP-based connection, because let's be honest, when we write code on our computer and we post it to an environment, sometimes it doesn't do what it's supposed to do because it's in a live environment. So we have develop, we have QA, we have staging, which would hypothetically be approved features. We make sure absolutely everything is working in staging, and once we know for sure, we go ahead and release the prod, and then that code is then live. Now, a couple thoughts on this is that couple things. The first is that this can be freaking nightmare fuel if you're not managing this process correctly. And what I mean by that is that perhaps you're taking too long to merge. You know, you're having this really wide open window from when it goes from develop to prod. And when I say wide window, I mean like a month. Like you're a developer, you write code, you get the feature done. A month later, it's still sitting in develop. Like that's bad 12-factor practice. Good 12-factor practice is that it goes through this entire ecosystem almost like 10 to 20 times a day. That's the utopia, is that you don't have major releases, you have mini releases. And you have an integrated team that's basically saying, like the QA is like literally working with the dev and be like, hey guys, that feature is good to go. QA checks it, they run integration tests, they make sure it's not gonna break it. We double check everything, and we might actually do this on the hour. That's like the utopia, but like it doesn't, you know, I haven't seen that in practice. So this factor, this dev prod parity is exactly that, is that this release cycle is so tight that it almost seems identical. It probably isn't, because your developers are cranking out features, but if you're running this correctly, you are releasing features pretty quickly because you have a streamlined process. And you can identify things when they go down and get them corrected. Okay. Not doing great on time, so I'm gonna make sure I can keep going here. Processes. So let's see, what do I want to say about processes? This is probably one I'm not gonna spend a ton of time on, but basically, processes that you create, when we say a process, we need anything that is server-like, anything that is like an application. And to be clear, when I talk about that, I'm kind of going back to, let's go back, but this idea. where we have these independent processes. Sometimes we call them servers, sometimes we call them services, but we've got these things created in isolation. And the key point of this particular factor is that they're stateless and that they're independent. And what I mean by that is that they have no notion of requiring values within the app itself. Basically, their values are provided either through environmental configuration or through persistent database. It's not dependent on anything else. Once again, I said that self-containedness is really important to this. I'm also going to remind you of something kind of critical too, is that if you have been learning development over the past 2 or 3 years, you probably don't know any better. You probably have never encountered a scenario where you've done anything but that. Because most of the modern frameworks allow for the statelessness and enforce the statelessness. And so that's why I'm probably not going to spend a ton of time into it, but execute the app as one or more stateless processes. So you can read more about that there. But once again, it goes back to that independentness of the little app that you're creating and making sure that can run and stand on its own 2 feet and not needing anything else from the operating system. It's got everything it needs from the dependency files. This is where containers come into play as well too. But yeah, this is another one of those great ones that you probably don't know any better on. This is called port binding. And essentially the idea is that your applications are bound by HTTP through a port. And so when we think about something like Express, Express, you would go ahead and create some code. So let's pull this up real quick. What do I want? Server. So here I am establishing through my Express app, and I'm saying, go ahead and start listening for connections on this particular port. If I were to spin up another service connected to a different database, I would use a different port. And if I were to set up a third one, a third port. And the way that these applications communicate with each other is through HTTP. And the idea here is that that is the way that these applications are set up. They are set up to be HTTP, stateless, and they communicate through the internet, or eventually the internet, because we might be doing localhost, but it's port bound. We communicate with applications through other ports. For example, if I were to have this app running and a secondary app running, port 5000 and port 5001, the way that the port 5000 app would communicate with the 5001 app would be to do a GET request to localhost 5001. So this is once again kind of encapsulating a communication method around each of our little services or each of our little servers. So back to our chart here, each of these steps would be port constrained. And the way that we talk to them is through doing HTTP requests between the services. Once again, you might not have done anything else, but there are other ways to do that. What are we doing on time? We're doing pretty good. Okay. Now here's the big one, concurrency. This is the one that if we do everything right, this is the magic of, I think, 12-factor apps and the magic of cloud altogether. And I've talked about this in other Aftercamp meetups before, is that if we're doing this right, if we have everything truly isolated, this is like architecture, services, Docker, Kubernetes, all these talks that kind of led up to this one point, is that if I'm doing everything correctly, I can scale up and scale down services on the fly. And so what I mean by that is that if we are on Black Friday on Amazon.com and I got orders going like crazy because I have all my Black Friday or Cyber Monday or whatever the heck deal I have going on, I can scale up instances of my service to allow for the traffic handling of all the people who are going to visit the site. And so now all of a sudden on Black Friday, I have multiple versions of my services that I'm able to spin up on the fly to account for all of this crazy traffic that's coming to my site. Now, let me paint the differential here for you. Let me talk about 15 years ago. Is that we didn't really have, we had cloud, but we had cloud in our literal office. There was a server room that you'd have to go open the door. It'd be 1,000,000 degrees in that freaking room. And we had server racks And if we wanted extra applications running, we have to go to the IT team, hand them the flash drive and say, put my code on this server so it can handle more traffic. But with the advent of these new cloud platforms, we're actually able to do this through something like the AWS console and say, hey, I need extra services because we are going to go crazy. In fact, I can auto schedule it. I can tell it to auto scale. You have to set some budgets because if you let auto scale, like all of a sudden you got like thousands of dollars worth of traffic that you didn't intend on, whatever. But if you've done the 12-factor app correctly, you should be able to do this like instantaneously. In fact, I'm going to bring in another factor here real quick, and that is disposability. So concurrency and disposability. So the idea is if I've built my services and my servers correctly, I can tear them up, or I can spin them up, and I can tear them down dynamically. And my application as a whole, when I say application, I mean my like entire service I'm offering, my entire SaaS. If this ecosystem is set up correctly, it can handle all the traffic. Now I want to pause for a second. You're like, Scott, nobody's going to trust me to do this just because I went to an Aftercamp. I totally agree. I don't even trust me, and I've been doing this for 10 years. I get tons of help. The goal tonight here is to make you aware that this is like stuff that we need to consider. In fact, this came up in conversation today at work. I had asked them like, hey, I wonder if we should abstract and put a service in between this other thing we need to interface with. That way we can create some fault tolerance if the need arises. And so really awareness of the 12-factor app is, if my team all knew 12-factor, they'd be like, okay, cool, I can see how that would fit into this architectural consideration for how to protect the system or how to scale up the system. Good question from Payton. Might be a bit off topic, but I wonder how much it costs for an auto-scaling server that is getting DDoS. So DDoS attack, by the way, is a cybersecurity attack. It's when direct denial of service. And what that's doing is that somebody probably created a bot that is sending out just like thousands and thousands and thousands and thousands of requests to a single server. And so the server is getting bombarded by traffic over and over again. Most of the cloud providers have DDoS protection, and they just like reroute the DDoS attack elsewhere. They're like, go attack over here. And so most, definitely Heroku, definitely GCP, and definitely Azure have DDoS attack is just kind of a thing now. It's pretty normal. So you're protected from the auto scaling standpoint, meaning that they have technology intelligent enough to be like, oh, this traffic is a DDoS attack, not real traffic. And that is part of the secret sauce and magic of those cloud platforms. Cool, for sure. Yeah, man. Anytime, Payton. Okay, so back to this concurrency thing. Concurrency, essentially, you can kind of think of this as scaling and the ability for our ecosystem, our SaaS product, to independently ramp up and ramp down sections of the app so that you can handle more traffic, you can handle more flow, and you can do that in a way that doesn't impact the whole system. Meaning that if you have a bunch of instances of the user service, it can adapt and basically take that traffic in, make sure everyone gets logged in, saves their updates or profile or whatever. You can probably think of like the user service needing to scale when an app launches and you have like a huge, massive amount of traffic, people signing up for the app. But after like a month of everyone signing up, user service is not that big of a deal. But then Black Friday comes around and the product service, all those users are now trying to make purchases through your site. Then purchases are made, everyone's waiting for deliveries, so that everyone's checking to see what the status of their order is. Now we need to scale up the order service because now we have that traffic again, looking at people trying to figure out where their order is. Then maybe you run a marketing campaign and you try to drive more signups. So now you need more user services because more people are coming to visit your site. Rinse and repeat, right? And the beauty of auto scaling is you only pay for what you need, hypothetically, right? You only pay for the services that the cloud provider is providing you. And the big win here is that I'm not walking into my server room telling my IT team, that we need to buy more hardware. Because like, think about that for a second, right? Like, hey, IT team, we're gonna have a lot of users sign up tomorrow, and we're gonna need more user services, more of our user apps running to handle all of the traffic in. They're like, well, I have to go buy all that hardware, get it shipped, get it installed, set up all the OS stuff, and it'll be ready in like 6 months. So 6 months later, have my servers finally, but guess what? The traffic is no longer there because people tried to sign up and they couldn't, and they kind of forgot about your app. So this all weaves into the beauty of the cloud providers and this cloud movements, right? It's going to things like AWS and saying, let's go ahead and set up auto scaling. They've got all this stuff hardwired and provisioned for us. All we need to do as developers is to write our apps in a way that are isolated and contained. And honestly, most graduates from boot camps leave pretty much ready to do that. The only other like consideration I could think of would be a module to elegantly tear down a provisioned server, and like that's a tutorial away. But I think the big takeaway here tonight is, I would imagine this to be a little bit confusing, and I totally get that. I think getting into the cloud ecosystem and figuring out, well, how does my React code fit into the grand scheme of things, or how does my Flask code, this little piece of functionality I'm writing, fit into the grander scheme of things, is that one of the things I always say is that sometimes you should be showing everything just to know what's there. And you don't need to know it all today. And I think that's like a big, like nasty habit we get into as programmers. Like once we see something, we want to like know it instantaneously. I have to go learn everything I need to know about 12 factor. You don't need to do that tonight. It's about awareness. Okay, I think I have one that I didn't touch. Disposability, once again, says this is the opposite of concurrency. This is like being able to tear down things gracefully. Oh, two more. Admin processes and then logs. Admin processes I'm going to kind of just lightly touch. And essentially it says run admin management tasks as one-off processes. Most of this is built into frameworks right now. In fact, this is the one that I ran into today. Is that a developer who was trying to isolate the migrate for the solution. If you're not familiar with data migrations, it's basically populating our framework with the data it needs. And so, if you are launching an application, you might need to migrate the data, but you only do it once. And so the idea is to isolate off that that thing you need to do and make it a process that you can just execute. And then the last one here that I want to talk about tonight is logs. And let me set up this little scenario for you. So once again, going back to our example of our ordering site, if this is a server, this is a server, this is a server, this is a server, and this is a server or service, they are all their own little independent Express apps, let's say. They all have their own little console logs telling you what's going on. So down here on the user interface, we tested things and something's not working. Let's say that we go to complete our checkout and it says server error. You want to take a stab at what server just failed? So basically we get a 500 on the front end saying, hey, server error, but take your pick, right? This is one of those nightmare things of microservices is go find the error. And it could be the gateway, it could be any number of these services that are failing. So you go through, you notice an error on product services, you're like, okay, product service, nope, that's not failing because it's pointing to something in the user service. Oh, just kidding, that's pointing to something in the order service. And you go through this whole chain. So what the 12-factor way to handle this is that we have some sort of like aggregate. We have some sort of, and there are lots of servers that are services that do this. You can sign up for online. But essentially, what you have is an event log that when you provision all of your services, they might actually use a technology, and they write all of their logs to this technology. And so what you end up getting is, this is a crappy line, so bear with me here, but you have a technology that aggregates all of the logs into one cohesive time stream. And so what you typically do in all your print statements or your log statements is like, here's the time and here's the service that reported it. So that when you go through and you look at your log service and you say, oh, okay, I can see the chain of events and what happened. Well, products failed because users failed. Well, it's because the order failed, but that's because the user failed. And so really this group was in some some get of a user out of the database, and it turns out that I just like actually just pointed to the wrong thing in my config file. But what's cool is you can go to one place to find all that versus having to go all over creation, all through all your services, all your microservices to figure out where the heck did the failure happen. So aggregating your logs becomes a really important thing in 12-factor, and trust me, like it has saved me hours of my life to have that organized that way. And once you do it, you don't ever want to go back. Okay, so that's the 12-factor. You know, I think you're like, Scott, how's this relate to me writing React front-end stuff? Honestly, I think that, you know, some of this is DevOpsy, some of this is really just like architect level. But I'm going to go back to, I think this is one of the single best things you can do for your career is just understand what your team is working on and understand what their concerns are. Because I'll tell you, as a guy who started in Flash 11, 12 years ago, I never thought I'd be like architecting stuff for the companies that I'm architecting for. Never thought I'd get to this point, but it sneaks up on you. It becomes, when you become that person in the room who's been doing it for a while, you just kind of get thrust into learning things that you didn't think you'd have to learn. So I'm really big on awareness. And I think that just being aware that this stuff exists and you're like, well, cool, I'm already doing 6 of them. Awesome. Just take a peek at the other 6 and start to try to wrap your head around what they allude to. Because as you go through your career, you know, over the next year, 2 years, 3 years, 5 years, you're going to run into this stuff. You're going to hear people talking about concurrency and disposability. And you're like, hey, I think I heard about that at a meetup 2 years ago. And hopefully the idea is that you're just clued in and tuned in a little bit more, because before you know it, you're going to be like, team, we need to aggregate all of our event streams into one tool, because I stayed up for 3 hours last night trying to find the error that because we didn't have that. So yeah, that's it. That's the presentation. I got about 6 minutes left before the top of the hour, before you guys probably want to go eat. What questions can I answer for you? Hey, thank you. I always get done with these and I'm like, Rachel, I bombed it. So I appreciate any feedback you have. That's great. Yeah, Peyton, I hate you. He goes 500, which is a server error. He goes, that sounds like a backend problem. Thanks, Chris.
I got something to follow up there, Scott. So I kind of was just writing notes to myself to ask the questions at the end.
Yeah, got you.
So we got, you know, for conflicting ports, you know, multiple applications and stuff, applications outside of the scope of your application use the same port. So when you're scaling up, how do we do that in the configurations to dynamically grab a free port?
Yeah, so most of the cloud solutions actually have that provision for you. So if you think about something like Heroku, a very common line we write in our code is something like this, where we say, hey, use the provided provision port or 5000. So what we're saying is, hey, application, go ahead and grab the provision port for me. And if that's not available, go ahead and grab the 5000 port. So typically in the auto scaling sense, it's actually provisioning the ports for you. And actually there's also some sort of load balancer that's pre-application that really balances out and directs that traffic for you.
Okay, yeah, because so like considering like say like Skype, I think that one runs off of port 80 or port 8080. And I know a lot of these are most ports are reserved or you know for certain applications that you know they won't even be issued. So this would, you were saying it'd be more of a provisioning team, the people that are actually deploying the application to these servers that would actually configure these things. Is that done manually or is that
Say that last part again.
Is it, you said the provision team, the people that would be deploying the application that would assign these ports?
The technology you're using typically has it auto provision for you.
Oh,
so Heroku automatically assigns support for you. And so like actually one of the ways you can check that out is if you wanted to, I could go.
So it's just like the other environment config files.
Yeah, I could go Heroku logs. Hypothetically, damn it.
See, the more you know.
Heroku.
Wealth of information. Thanks, Scott.
Yeah. I see a couple hands up. I think I'm sorry if I pronounced the name wrong. Dewey.
Dewey.
Yeah.
Yep. Thanks for putting this together. It's been super helpful. Just a quick question. So do any of these 12-point factors come up in like as a new dev applying for jobs? How often do these come up in interviews, if at all?
That's such a great question. I'll tell you, I think a couple thoughts on this. I was working with a developer today. He is a senior developer, senior backend developer, and brilliant guy. Like really, like love this dude to death. He stays paid and I ask his day on a daily basis. And I was like, hey man, so you know, you're definitely hitting on all these, and like 12-factor stopped behind me because I knew I was gonna give this talk tonight. And he's like, 12-factor, what's that? So he goes and Googles it. He's like, I didn't even hear it called 12-factor, but I've been doing most of this stuff. So I think it's tricky because the name 12-factor may or may not be a thing, like maybe with your interviewer, right? Like there's a lot of like this industry has gotten promoted quickly, and there's no standardization on who's a senior, who's a principal, who's a manager. And so the quality varies of who the interviewer is. But I will tell you, the thing that I feel like is universal, and most of the hiring managers that I talk about or talk to, is that once again, if you can get to the point where you can understand how your systems work, right? Because most of us kind of start off currently in this front end side of things. And like we have a little bit of this back end stuff and we don't have a ton of it. So, you know, what I like as a person who hires somebody, if I'm hiring like a junior or a mid, like if you rattle off the 12-factor, all I'm going to really think that you did is like study the night before, and that you can speak to it and articulate it. But I think if you can get into the point where you like really understand kind of like cloud, like you understand, oh, like I did AWS and I launched my app on Elastic Beanstalk, and then I also am talking to an S3 server to get, you know, to load my images up there. And you can kind of walk through an architectural chart and like tell the interviewer like what you did. That'll always be impressive, because I think the thing that we really find in a lot of developers is they know like how to solve a discrete problem, but sometimes they don't understand how that fits into the bigger picture. So the more you can paint the bigger picture for people, the better.
Awesome.
Yeah,
that totally answers. I appreciate it. Thank you.
yeah, for sure. Chris or Charles, I saw your hand up.
Yeah, thanks. So I thought it was a great presentation, and honestly, like I've seen some of these topics occur in other organizations where explaining just the separation of concerns by adding additional servers and applications on your server stack, like is super helpful, and it develops like centers of knowledge. But like I was wondering, like in terms of 12-factor, beyond that, if you're setting up like an API organization, and you know it could be in the form of API management, or for instance, maybe we're just looking at ways to just start producing APIs for internal consumers. Like, is there anything different outside of what you talked about today to bring into consideration?
No, in fact, as I was pulling notes, I really thought it was kind of funny that through multiple channels, people are like, look, just start with something. It doesn't matter how big or small it is. They're like, dude, start with like a hello world API, like just something that just returns hello world. Like, I think that scale is not like, oh, I'm going to write a huge API, or like an API is going to get a lot of traffic, therefore I should do 12-factor. It's kind of the opposite. It's like, it's just, they're good standards to like kind of live by, because I'll tell you, especially like in the startup world, like ideally in the startup world, like, you know, your version 1, you're like chewing through ideas like crazy. And it's like, oh wait, this idea is like really catching on. So this V1 of this app, we need to like scale it like crazy. So, you know, I think it's just a good set of principles to live by. Like, but I'll be honest with you, like I have like a hard time being like, I'm going to set up dev and staging and prod for like my little app that I created. Like sometimes it doesn't make sense. And so I think it's really about, you know, what are you trying to accomplish? You know, I think I'd probably run my team through the ringer on 12-factor, even on a hello world, if I was trying to get them to like the discipline of it down, right? Like guys, like I understand that this is like a really simple little API that like 3 people are going to use, but I'm going to put you through the paces because it doesn't matter here, but it's going to matter when we write the bigger ones as well too. So it's really all about,
Okay, I just had that conversation with somebody, and yeah, you're confirming a couple of things there. Thanks.
Yeah, cool. Ronald, I saw your hand up and you had it in the chat. Do you want to ask me directly, or do you want to read it for you?
You know, so my question is, well, I guess slightly technical. When we're working with the concurrency and the scaling, I get how we can like scale the servers, you know, more requests, more servers, and that kind of stuff. one thing that I'm fuzzy about is like, how do we scale databases? And this might not be something that I have to worry about thinking about 12-factor applications. I'm just wondering, because all the data needs to be in sync, right?
Yeah. Yeah, that's such a good point, right? Because like so the question kind of centers around, this is like, I got a huge, can I say that client? I don't know if I can say the client. We had this issue with a Fortune 10 client, worldwide organization. So not only do we have to do a scale, but we have to do with like edge computing. So like basically like how does somebody in Sweden access data in Mexico, like that whole thing, like that whole problem. And then there's a ton of data. So how do we provision more databases and then get parity? That could be a talk in itself, man. I don't, you can feel free to shoot me a LinkedIn message and maybe we can kind of chat about offline. That would be at least another hour. So feel free to hit me up and we'll definitely, we can jam on it for a bit. Cool. Friends, thank you for coming tonight. Next one is actually solid principles, and that's going to be really focusing on the Node Express ecosystem. I think you could also work really well for like Flask. And I think that one of the things I've noticed in talking to junior developers who go through programs like this, where they do Flask or they do Express, they love to get a solid handle on good architectures and good patterns to follow. And they're like, well, what's a good pattern to Express? Like, have you looked into solid? They're like, yeah, but I don't get it. So what we're going to do is we're going to marry those modern micro frameworks with solid principles and kind of talk about how you can take away some of that stuff and create some good architecture. But thank you for coming tonight. I'll see you guys in November, and we'll have this recording up here in a bit. Have a great night, everyone.